call, sorry for disturbing. Where we are, okay. So this is normally NC. Suppose if this is normally NC as per the circuit, you can see in the circuit drawing, in the channel number, if it is put NC means it is, suppose it becomes NO, then only the alarm will come. Okay, here you will have an option in the AMS. You need an alarm. If you select this channel, okay, 23, you have to first select the alarm and then go to alarm tags. Then you will see all these things. Okay, from which channel number the alarm is coming. So there you can see NCNO. Okay, so if it is circuit, if it is in the circuit as per NC, no, here also it would have been set as NC. Okay, that means what? When it becomes NO, only the alarm will come. Correct, no? So sometimes what electricians do is they uncheck this and check this. That is also a way of inhibiting. By doing like this, what he is trying to tell, when the circuit becomes NC, then you trigger an alarm, not during NO. Understood? Why I am telling you is, this is a part of configuration. This comes as a part of configuration, configuring a spare port. So other ports I am listing. Just for example, this is a spare port. These two are spare port. You want one alarm in the AMS. Okay. So okay, this is okay. So what is happening? Up to here you can give connection. You can install the sensor, give connection to up to data acquisition unit. You can give the physical connection. Okay, by connecting using the spare ports and all. But configuring this port, suppose this is 40. This AMS, which is having a software inside, it doesn't know that you have done all these things. You have to configure this port with the software. You have to integrate it basically with the AMS software. So for that you have to do using the admin username and password. See, the other things and all, you have to use for changing the values or inhibiting or something. You can log in through username password, but this is admin user. So admin user, he won't allow you to integrate this port. In the sense, you need to create a new channel tag inside the AMS software for this one to recognize this alarm, this signal basically. So you have to tell to the AMS, suppose if this circuit you want to make it as NO normal and give an alarm when it is coming to NC, the same has to be integrated in the AMS software. So for this, sometimes they will give the password, then you can configure and he will give you the procedure of how for the configuration. But sometimes what happens is, AMS maker, mostly Kongsberg or whatever, whoever, he will tell that I will only come and do. So this was actually the argument happening when we were doing scrubber installation. My electrician gave up to here. Up to here the job is done. So from the ship side the job is done. So here I need one alarm called scrubber abnormal in the AMS or whatever. What happened to me I am telling. We were there in the installation of scrubber. That time I need an alarm here in AMS. So then for that they were asking charges for attending for vessel attendance, and then ultimately the company has to budge. Okay, you come and configure. That time you opened this admin password, then he configured the ports. So this is one of the things which I wanted to share with you. what I am why I am telling all these things is, you will never know regarding when you go for oral examination and all, you will never know who anybody can ask anything. We cannot expect, if you happen to meet a sailing chief engineer coming for externals, no, then with the present day automations, definitely he will expect something. So that's why I am telling, I am here to give you a broader idea so that you won't be lost. So this is my motive. At least you can tell something. See, whatever I am telling, it is just an outline. Please don't feel that I have gone in detail. I am just giving you an outline of what is happening. These things, as I told you before, it is just my experiences with my ETOs. So usually when you have a trainee ETO, which is usually most of the cases, they can understand the wiring diagram, but they need to discuss with chief engineer how that sensor is, what is the purpose of the sensor in the system. For example, in ME engine you have a feedback sensor, right, the exhaust valve. So he knows it is a feedback sensor, that's all. So, but he doesn't know that the feedback sensor, its output, which it is giving the travel of the exhaust valve, which is giving its output to the MOP, that is one of the functions which is taken by the MOP for controlling auto tuning. All these things, so that is one of the parameters for the engine to which auto tuning, as you know very well, people who have worked in electronic engines, the engine will be in auto tune condition. So that is one of the parameters which is being taken for the engine to auto tune, for adjusting the exhaust valve timing to make the PCOM even. While taking ME engine sessions, definitely I will be interested to tell you all these things. Okay. Now another thing which we intend to discuss is, most of them know, just a recap, what happens basically when you have a generator running, okay, and when you start a big load or any automatic bigger load is started, like main air compressor or something, okay. This is MSB, your bus bar, okay. This is the consumer. Just imagine like this. This is the supply from alternators, 440 volt supply, okay. This is the consumer. Suppose this is a main air compressor. Just wanted to recap a little bit here and there, especially for class 4 students. It's for their understanding, basically. So here suppose if one generator is running and you have main air compressor getting started in auto. So what happens first? The bus bar will try to draw more current from the alternator windings, okay. When it tries to draw more current from the alternator, the frequency drops. So the prime mover has to turn more to match the frequency. So how all these things is happening is, once the RPM drops, when the current is drawn more, the RPM of the alternator will drop, which in turn the prime mover, ultimately the RPM of the prime mover will also drop. So here what is happening? This is the flywheel. Okay. This is the flywheel of a generator. This is the alternator, no? Imagine something like this roughly. So in the flywheel, there is a tacho pickup, no? You have a tacho sensor pickup. So this will give its feed to the, I am telling about the present day generators. Before it was little different and now it is different, okay? Before it is different means basic working was the same. But now present day engines, present day ships, I am telling what I mean by present day ships means about 5 to 6 year old vessels. Here you have in the generator panel, I am telling when you go near the in front of the generator, you have a panel, no, where you start and all, and where you can see lot of other parameters, turbocharger RPM, lube oil pressure. This is the, we call it as module. Okay, here you will have a display, RPM display. Correct, no? So this is coming from the tacho sensor will give analog signal which gets converted into analog to digital converter and then gives in the module as suppose 25,000 RPM or 30,000 RPM generator turbocharger RPM I am telling. So suppose if this is for your display, but there is one more thing. At the tacho, suppose if the load is cut in, there will be a drop in the RPM. So what you want, because of it, as you know very well, it tends to draw more current from the alternator windings. So the RPM drops, frequency will drop, and then the drop in RPM is sensed by the tacho pickup sensor, which gives its feed, its output to the module. Okay, then from the module, this is a governor. Okay, just assume that this is a governor. This is a governor. You will have a governor motor, usually DC motor. This is called a governor motor, no? Telling you would have noticed. So what will happen is this module is giving signal to the DC motor. That means it is signaling to the governor to give more fuel to the engine. Okay, this is what is happening. So you would have wondered, okay, if the RPM is dropping, how the governor is taking care? Everybody will tell governor adjust the function of the governor is to maintain the constant RPM of the prime mover. But how it is doing is this PLC module will give a digital signal. This is a digital signal, okay? Digital signal to the governor voltage, basically voltage signal to the governor motor. Okay, governor motor usually will be a DC motor. So this will give voltage signal to the motor and then tell it to increase. Okay, when you want to reduce also, same thing is happening. Okay, and suppose if you would have noticed in the ECR also, there will be like increase decrease. Okay, in the synchronization panel, that will also give signal to the DC motor when two generators are running. But that time, you would have noticed in the generator PMS panel, no, you have the sets of, in the individual this thing also increase decrease. What is that thing is doing is, suppose if that is the increase decrease this thing for one, this will give signal to the governor motor. When two generators are running and when one high load kicks in, this is what will happen. But both the governors have checked the drop in the RPM and then they have increased the fuel. But there is another increase of AVR. This you already know. So what AVR does is fine tuning. The AVR detects the output voltage and accordingly it gives the excitation to the alternator windings. That's why there is always the major work is being done by the governor for increasing the RPM. The fine tuning is being done by the AVR. Okay, that you remember. You already know all these things which you would have of course studied in your engineering. These are all basic electrical. But the present day ships, because from the module, because I have also learnt for these things there is a change. Before there was no PLC module. Everything was happening through relays and contacts. Okay, but now we don't see any those kind of systems. We have a PLC module where, so that's why suppose if PLC module is gone due to battery or something, or motherboard is gone, you cannot start the generator. This is the heart of the generator right now. In the sense, especially for new ships, and it is advisable. Some companies will give one module as spare also. You just keep it on board, because you cannot start the generator till you have the module working. So here what I am trying to tell is, from MSB, when two generators are running, you would have noticed sometime tuck tuck sound coming from the MSB, the synchronization panel, where these switches, which because the PMS system is in auto, these switches will give one generator you increase and another generator you decrease. These signals will go to, suppose for AE1, this is for AE2. Just for example, I am taking. These are all voltage signal. Okay, analog signals going from MSB to governor motor of AE1. Consider this AE2. This is a governor motor. So this will tell this one to increase, this one to little decrease, so that the bus bar frequency and bus bar voltage is steady. Okay, as per the governor settings or droop settings also. So I hope this has been useful to you, and another simple type of control system is, for example, dump controller. Why I am discussing certain topics is, this is common for all kind of ships, bulk carrier or tanker or whatever kind of vessels which you are in. How a controller works. So actually I can tell right now, but I need to get a photo of my ship so that for your explanation, but I think I can do that in my online class. As I told you already, it is difficult for me because right now I am on board, so I don't have a Google class and all. So I will just give you a basic. Okay, just for example, this is the boiler panel where you have a provision for setting of dump controller. Okay, dump setting, you have a provision. Your HMI panel. Okay. Dump set point here. Some value were set. Okay. So after setting the value, after you give the enter button, again as I told you, digital signal will go, and this digital signal will get converted into processor unit, where we have DTA converter. Okay, in the digital to analog converter, you have here now it's a analog signal. Okay, from here it goes to IP converter. What IP converter does is, whatever analog signal it is receiving, corresponding pneumatic signal it will convert. Okay, it will have a pneumatic supply, a controlled pneumatic service air supply. Okay, and you will have a reducer and all, orifice and all. As per the pneumatic analog signal, current signal which you are getting, this is what we call as IP converters. Accordingly, it will give a pneumatic signal. Okay, here you have this line, dump controller boiler steam thing for the main line. Here, as per the this will give signal to the motor controller or motor actuator. This control valves, if you see now in the any controller valve, steam controller or fuel oil temperature controller or whichever is the controller valve, you will have something like this, no? One manual handle also will be there. This is a manual handle. This is a pneumatic line. Okay, and here you have a, this is the, just assume this is the main line. Okay, accordingly here you will have pneumatic system, which is this what we call as a actuator. This here you will have a motor actuator or valve actuator, whatever you can call. This is a manual. There will be a provision for manual also. Okay, construction of this valve in detail right now I cannot give, because better I have to explain it with the drawing, which I hope that you also are aware of. So what this one does is, this pneumatic control from the IP controller output, it will come here and then act on the motor actuator. Then depending on the pneumatic signal, the amount of air pressure coming, this will operate this valve. Okay, whether to open or close, how much to open, how much to close, depend on the pneumatic signal.
Your attention please. Ship's clocks will be advanced by 1 hour at 1300. I repeat, ship's clocks will be advanced by 1 hour at 1300. जहाज की सारी गाड़ियां दोपहर को 1 बजे 1 घंटा आगे कर दी जाएंगी.
Thank you for that. And I hope now you got a brief idea what is happening. So processor unit, and then it's going to, from the your analog signal, current signal will be converted into corresponding pneumatic signal. This pneumatic signal goes to the motor actuator, which in turn operates the pneumatic valve of the controller. Okay, this is a valve. If you see in the drawing, valve control system, if you can refer to that, you will know the construction of this valve and how it is operating as per the pneumatic pressure, given how these things are operating. So when to, how much to open, how much to close. Okay, and another thing is, this is having a feedback also. You need to have a feedback, no? Same, again this will get, okay, I have sensed the setting is as per, there are two types of control, no? One is open loop, other one is closed loop, no? Mostly on board we have closed loop, where we have a feedback coming. So same thing is happening. Here you will have a micro switch also in this this thing in the valve controller, or here also which is traveling, which is giving the travel. With that also there will be a feedback. And another thing is the parameter of whatever you want to control. So how much you want to dump. So that feedback, again there will be a sensor. How much is the this thing, and then it will go to analog to digital converter and then go to the boiler control panel and giving the feedback continuously. So as per the feedback which is coming, same circuit again, okay, as per the feedback this will give command, because you have already set. So you have set at one value and I am getting a certain value as a feedback. Accordingly I will give the pneumatic pressure for the valve to operate. Okay. So when I explain you about I intend to explain this in my online classroom, how a simple jacket water controller is working using PID controls. Okay, these are all basically PID controllers. So that time I can explain you in a more better way, because I will be using Google Classroom or something, or Zoom or something. So I can share with the things while teaching how is the system operating. Okay, these are all, please assume this as a rough idea only. Okay, thanks for listening guys, and I hope these things will be useful to you. This signing off is Krishnan. I am signing off. Thank you.